Example 2.6. How many ways can a four-digit number greater than 3000 be formed using the digits 0, 1, 3, 4, and 5 if, firstly, no repetition of digit is allowed? So let's consider the four digits, 1, 2, 3, 4. So I need a number bigger than 3000. So that means in this first box I can only put either 3, 4, or 5. So I've got three choices here. But after I've assigned one of these three digits to the thousands column, I now have no other restrictions other than I can't repeat. So here I can then put in four different choices, three different choices left for my third digit, and then two choices left for my final digit. So this means that I have the number of ways is 3 times 4 times 3 times 2, and that's equal to 72 different ways. Is it? Yes, 8 times 9, good. Okay, so what about if I do allow repetition of digits? Well, again, I look at my four digits that I've got, first digit, second digit, third digit, fourth digit. Still in the first column, I have three choices, needs to be a 3, a 4, or 5, but now I've got no restrictions on what can go into these final three boxes, so I can put any 5 of them in here, any 5 of them in here, and any 5 of them in here. So that gives me 3 times 5 cubed, and that is equal to 375. There's just one thing to be careful of. What happens if I assign the digits 3, 0, 0, 0? Because remember, I have to get my number to be greater than 3000, so I need to go 375 minus 1. So there are 374 ways. The third question, these numbers formed without repetition are even. So there are two cases to be aware of here. Case 1 is where 0 is the final digit, and case 2 is where 4 is the final digit. And these two cases arise, why? Because I may need 4 in here. So if I'm assigning 4 to my last box, it changes what I can assign to my first box. What do I mean? Well, let's look at 0 first, my 4 digits. I've put my 0 here already, so I've only got one choice for what goes in here. In this box I can put my 3, my 4, or my 5, so I still have 3 choices in here. How many choices do I have for my second box now? Well, I can't use whatever I put in here, and I can't use 0, so I've got 3 choices for this, 2 choices for this. So I've got 3 times 3 times 2 times 1 choices. That is 18. 18 ways where 0 is the final digit. What about when 4 is the final digit? Well, again, let's take a look at what happens. 1, 2, 3, 4 boxes, and I assign 4 as the final digit, so only one choice for that. How many choices do I have for the first one now? Well, I can either assign 3 or I can assign 5. So I've only got 2 choices in here now, and then I again have 3 choices in here and 2 choices in here. So now I've got 2 times 3 times 2 times 1, and that gives me 12 choices. So the total number of ways to arrange the digits is 18 plus 2, two disjoint cases. I can't have both 0 and 4 as the final digit, so I have 30 ways